I am here to lead you on your virtual field trip. We are here at Pigeon Point Lighthouse. That's the lighthouse in the back. What's kind of cool, it's a lighthouse that doesn't work right now, but they're working on restoring it. We are very near Pescadero, California, which is in between Half Moon Bay and Santa Cruz. If you go that way, you'll hit Santa Cruz. If you go that way, you'll hit Half Moon Bay. And we are here at one of the best intertidal sites that is free. I always take my class here every quarter. Why? Because there's ample parking. There's a great, turn to me, Karen. There's a great landmark, the lighthouse, so it's easy to find. And there are restrooms at the lighthouse. So this is why I always bring my classes here, because there's restrooms, it's easy to find with the lighthouse, and there's plenty of parking, and most importantly, there's a lovely intertidal site down below, and we're gonna take you there. Karen, our camera person, and me, we're gonna lead you on this field trip to discover intertidal organisms. Let's go! We are in the intertidal. So there are three major zones of the intertidal: the low intertidal, the mid intertidal, and the high intertidal. We are in the high intertidal, the furthest away from the water. And as you can see, camera person, there's not as much light here because there's not as much water that gets to this area. We will see some creatures over there, like over there, you can see some algae. And as we get closer and closer to the water, we will see more and more creatures. But we are in the high intertidal, the furthest away from the water. This is only covered at high tide. And like I said, we're out here in low tide. So there's nothing here, not as many creatures, but you're gonna see as we get lower and lower, closer and closer to the water, we're gonna see more and more organisms, and let's go see some organisms. Okay, so we are still in this high intertidal. I just wanted to walk a few steps down to where we filmed before, and let's introduce you to some creatures. So down here, get a close look at these. These are barnacles. These are specifically called Cathamelis and Balanus. Balanus are the larger ones, which I don't see too many of them, but I do see a lot of Cathamelis. You can see them up here. Each of these are called a Cathamelis. And they can survive in the high intertidal because they can close up when there's no water. Once the high tide comes in and water covers them, they will open up, and they have little appendages that capture food. So if you can go to my hand, camera person, they kind of have these appendages that come out, and then they kind of let the creatures, the tide moves creatures on these appendages, and that's what they eat with, and they eat with that. Another interesting fact about barnacles, I'm gonna get a little dirty here, a little X-rated here. Barnacles have the largest penis size to body ratio of any organism, except for Renfield. Just kidding, just kidding. Renfield was my dog, just kidding. Barnacles have the largest penis to body size. Why do they have the largest penis to body size? How does that help them? Well, if you're a barnacle right here, and you gotta fertilize another barnacle right here, you better have a large appendage, for God's sakes. So as you can see, they're stuck in one place, so they have evolved a very large penis so they can impregnate other barnacles. And what's interesting, they are hermaphroditic. So if there's not one close enough where their large penis can penetrate, they can fertilize themselves. I know, too much information about the barnacles. Some more organisms down here. We have Tegula, that's the scientific name. The genus, this is Tegula, the black turban snail. As you can see, they're all over here. They're all over here, okay? We also have some smaller snails here, okay? Some more snails for you. So we have barnacles, we have the snails, and we also have organisms like limpets. That's a limpet. If I had a little spatula, I don't want to kill anything here, but if I wanted to have a little spatula and knock it off, you'd see a little foot that keeps it really tight on the ground. So it's hard to, I can't even get it off with my fingers. If I had a little spatula here, a little knife, I could probably pry it off. Let's see what else we can find here. Oh, I know. Wait, this is just sand over here. This is just sand over here. Actually, it's not sand over, oh wait, what's this? Oh my God, wait. This is what I think it is? Yeah, oh yeah, okay. We have a baby hermit crab. I don't know if it'll come out. I saw this snail moving. It's a baby hermit crab. Really small, maybe not baby, but it's a small hermit crab. I'm hoping it comes out. It may not. If not, you can kind of see I don't know if you can see it, but you can see his little claws in there. Camera person, can you just make out the claws in there maybe? There are claws in there. That is a hermit crab. Let's see if I put it in the water, if it'll start moving. Let's see if I put it down here. Let's see if it starts moving. I don't know. I don't know. While we're waiting for it to walk, I will show you other creatures here. So this may look like sand to you. It is not sand. It is an anemone. These are anemones. They cover themselves with sand in order to protect themselves from the sun. This is all anemone. Not say they cover themselves with sand, but this is sea anemone. I will show you larger sea anemones. Oh, it's moving! I told you it was a hermit crab. Oh, it's getting away. There's that hermit crab moving away. So some of these snails are actually not snails, they're hermit crabs. That's a snail. Most of them are snails, but we found that one hermit crab. Yay us. Oh, there it is. Yeah, there it is. Oh, oh. Oh, it's hiding again. But then, yeah, that is a hermit crab. So we have anemones. These are all anemones. Who wants to hear my bad anemone joke? I think I might have told you this in a lecture, but that's okay. I'll say it here too. So what's kind of cool about the intertidal, anemones, they don't get eaten by anything. Nothing eats the anemones out here. What limits their population is that they will attack each other. So if you see this anemone over here, they can actually move. They can move a little bit. And if they come in contact with another anemone, they will attack that anemone with special tentacles called aquaragi. That is true. This is a true story. It's going to lead to a joke, but right now it's just a story. So they have tentacles called aquaragi, which they attack each other with. So nothing eats them, but they attack each other, which limits their population. So in a sense, they're their own worst anemone. Their own worst anemone. Thank you. Okay, let's keep going with some more creatures down here. We have barnacles. We have our first species of algae here. So this is called Turkish towel. Turkish towel, scientific name Metacarpus. Why it's called Turkish towel? You see those bumps? Now look what I can do with my face. I rub it on my face. It's like a towel, Turkish towel. So it's like a towel, Turkish towel. So that's an algae. Oh, down here. So that's called a red algae based on its color. You see it's kind of a pinkish, brownish color. That is red algae. Here we have, so green algae is the hardest to find. This is a green algae right here. As you can see, it's a green algae because it's freaking green. Mainly chlorophyll. It has a lot of chlorophyll, very few accessory pigments. This is called the green pincushion algae. Green pincushion algae. Yeah, it's so one of the few greens we'll find. Okay, so that's a green pincushion. Okay, and there's some more there, green pincushion. But mainly we have the Turkish towel over here. Okay, so we talked about the limpets. We talked about the barnacles. We talked about the black turban snail. I think we can move on. Okay, so we're just a few steps away. And as you can see, these zones of intertidal, high, mid, and low, they range because the rocks range from high to lower. So for example, there's a lot more water here. And so we get larger anemones than we saw earlier. These are solitary forms of the anemone that we saw earlier. And as you can see, they put sand on themselves to block the sun. This is there for sun protection, which is really kind of cool. They actually take their tentacles. Their tentacles are not out right now because it's a low tide. When they are covered with water, their tentacles will come out. And like I said, they will attack each other. If this one moves close enough to this one, they will fight. They will put out those special tentacles called aquaragi. Aquaragi. A-C-R-O-R-H-A-G-I. They will fight each other. But what's cool about them, you can see what they've eaten. Here, I'm going to use my special finger. This is my special finger. I'm going to see what they've eaten. And what's cool about these creatures, they are so simple. They have one hole, a gut that is also what, if they can't digest it, they spit it out. So I'm sticking my finger inside there, seeing if there's anything in there that I can take out to show you. And there's not. Oh, there's something in there. There's something in there. Ow, ow! Just kidding. Look what I found. I found a brown turban snail. The turban snail. Yeah, Tacula. I found that in there. Oh, and is it a? Oh, it's a dead snail. There we go. But I found that inside. Let's do it for this one. Yeah, that's what's kind of cool. You can see what they've eaten, or what they're in the process of eating that I'm taking away. Okay, nothing in there. Yeah. So special tool. You can always bring this with you to the intertidal, and you can see what they've eaten. So these are larger versions of the anemones we saw before. So the ones we saw before with the sandy stuff, that is called the colonial version. These are solitary. These are, so let's see if I can get, oh no, okay, I can't. But these are solitary versions. So here's another type of algae. It's called sea lettuce. Sea lettuce, that's the common name. Pretty cool. Sea lettuce. I usually don't find sea lettuce here, but in that little patch here, I wanted to show that to you. And all these seaweeds, they are algae, forms of algae, large forms of algae. In Kingdom Protista, we're going to get to that later. But what's really cool is that there are some plants in the intertidal. Very few. Very few. And we're going to get to one. Down here, pop in the water. And we have a seagrass. A seagrass. This is actually a plant. There are very few plants that can survive in the ocean. This is one of them. One of the few plants. Kingdom Plantae. All the seaweeds are Kingdom Protista. This is a whole different kingdom. This is a plant. One of the few plants found in the ocean environment. This is called the seagrass. It is right down here for you. And what's kind of cool, as we get more water, we get different kinds of algae. You can see that red algae down there. It's called coralline algae. I'm going to take a little piece out for you. This is called coralline algae, a type of red algae. Why it's called coralline algae? It's kind of crunchy. It's kind of crunchy. It has calcium carbonate in its leaves that gives it that crunchy feel. Calcium carbonate is also the substance found in coral. So this is called coralline algae. Coralline algae because it has the same kind of molecule that coral does. Calcium carbonate. Calcium carbonate. Okay, so remember we saw the solitary anemones a little while ago, and actually down here, here's that solitary, and you can see the solitary. You can see its tentacles out. So again, those special tentacles that they use against each other, they only bring them out against each other. They're there. I'm not going to get them. I have to kill this anemone, but I can see what's eaten. Oh, anything in there? Okay. Anyway, so that's the solitary form. Up here, you have the colonial form. You may have walked by this and said, oh, it's sand. It's actually anemones. These are all anemones, the colonial form. So the solitary form down there, the colonial form up here. Okay, and we have different species of algae, another red algae. This is called Endocladia. Endocladia, that's the scientific name. It's the bushy algae we see here. So we have our Turkish towel, and we have Endocladia, kind of the bushy red algae that we see here. Okay. Okay, so this is a really cool sight to see. So anemones, they can sexually reproduce. They can also asexually reproduce, simply split in two. And this is what I think is happening here. I think this is an anemone splitting in two. I think it'll have two holes that I can put my finger in. Yeah, there's one, and here's another. So this was an anemone that was splitting in two, reproducing asexually. Kind of a cool thing. I don't remember if I've ever seen one of those before here. So cool find. Okay, phone here. This is an action shot right now. Oh, there it is. Okay, you see that red on the left, that top left, that is a sponge. So I wanted to get that video for you. Sponge right there. And action shot we found. Oh, first off, anemones. Let's look at the anemones right here. Oh my God, Mr. Anemone. Okay, so we saw a sponge here. You can see let me get that red sponge for you right here. That is a close-up of sponge. You can also see that pink right below the sponge. So the red is the sponge. Below that is pink. That is also a form of coralline algae. Coralline algae. It's encrusting coralline algae. Before the coralline algae was branching, much like just algae branching out. This one is encrusted to the rock. That pink down there, that's encrusting coralline. Some more encrusting coralline along with our friend Mr. Anemone. Okay, so let's go find this. There's a starfish over here, action shot here. Okay, this is our first sea star, Pisaster ocraceus, the ochre sea star. The ochre sea star, it's beautiful, beautiful. Ochre sea star. I'm going to see if I can get it up. I'm going to hand this back to camera person, see if I can get this up. I'm not going to damage it. If it's stuck in there too much, yeah, I'm not going to really damage it. But that is the ochre sea star, Pisaster ocraceus. And as you can see here, we're down in the lower intertidal, covered with stuff. There's barely any open space. And as you can see, we've hit a mussel bed. Our camera person is looking at the mussel bed, getting all the mussels for you. And these sea stars, if you go back to the sea stars, what these sea stars do, they feed on the mussels. It's kind of a slow-moving war, but what they do, they crawl over to the mussels when it's high tide, so they wait till the water has come. They're not going to move. The only way they'll move is if I pull them off, which I'm not going to, but they feed on these mussels. And how they feed on these mussels, they actually have two stomachs. One stomach they put out of their body. Come to me, camera woman, look at my face. They comes out of their body, they go, comes out of their body, and they put that stomach inside the mussel shell. How they do it? They have tube feet. They have tube feet that they wrap around the mussel, and they slowly, it takes hours. They slowly open that mussel up just a crack, and then they put their stomach inside and feed on the inner parts of the mussel. It is really cool. So this guy feeds on the mussels here. Oh, and something we forgot to tell you, here's gooseneck barnacles. In between the mussels, here's a mussel, here's a mussel. These are gooseneck barnacles, a form of barnacle. Okay, we saw other barnacles here. We have Cathamelis here, just like we saw in the upper intertidal. We also now have gooseneck barnacles. They like it lower. So these barnacles can live everywhere, high, low, mid, but the gooseneck barnacles we find a little lower in the intertidal. Yes. Okay. So we have two species of sea star over here. This is called a bat star, Pateria. Oh, and I told you how they avert their stomachs? This guy has its stomach averted. Can you get close up? You see, that's its stomach. You see that little bubble thing in the center? That is its stomach. The bubble thing in the center is its stomach, and you can see its tube feet. Its tube feet are moving. You can see its tube feet moving. Those tube feet are how it opens the mussels. The tube feet are how it moves and how it opens the mussels. And we have our other sea star down here, another Pisaster ocraceus, the ochre sea star. Same species as the one we saw before, back there, the darker one. That's another one, Pisaster ocraceus. So the bat star, Pateria, and then Pisaster ocraceus, the ochre sea star. Awesome, awesome, awesome. I am so excited for you right now. We found another sea star, Pisaster ocraceus, right down there. And there's an anemone right there. But the star of this show, the amazing, amazing sea palm. This algae is amazing because it thrives in high wave environments. All these sea palms you see here, it's a treat because they're not always here. They are an amazing species of algae, and they are edible. You can eat them. Here, I'll do one right now. You ready? Okay, here. Okay, here we go, Okay, they're edible. They're edible. They taste like steak. Just kidding. They taste salty. But anyway, this is called the sea palm. Postelsia is the scientific name. They are amazing creatures in that they thrive in high wave environments. When they're a baby, when they're their kind of earliest embryonic form, they have this sticky substance that allows them to stick onto the rock and stay there until they grow to what they are. What's a treat about seeing them, they're not always here. They're very, let me spit this out. Anyway, they're a very seasonal plant in that, seasonal algae in that they're not here all the time. Sometimes I take my classes here, they're not here. And sometimes they are here. And look at them, they're in abundance, they're all over. This sea palm, this Nelson is a sea palm. A beautiful algae. Oh my gosh, so anyway, we are finding hella sea stars. I'm amazed. I've never seen so many sea stars at the site on one of these trips, and this is amazing. And I'll tell you why. Because about a decade ago, there was a disease called wasting. It basically destroyed the sea stars by wasting them away. So they died from this virus, and sea stars lost a lot of their population because of it. It's the wasting disease. Basically, their arms would fall off. Their arms would detach. They would die from this virus. Now, the sea stars have been coming back because of mutation and evolution. The ones that have been able to fight off this virus have survived, and they are in abundance now. I'm actually shocked how many sea stars we're finding. It's nice to see their population rebounding. And again, it's wasting disease that their populations were really brought down low. And now I am I'm shocked at how many sea stars we're seeing here today. So awesome story, awesome to hear. Okay, let's move on. Okay, and as you can see, it is covered with organisms. We are at the low intertidal. Where the waves are coming in, you can see the mussel bed. You can see all the algae here. Space is at a premium here. And we're gonna get to our last organism of the day, urchins, sea urchins. In here, there's sea urchins. I have my urchin removal tool right here. If you wanna look at this, it's an urchin removal tool. Some people call it a key. I call it an urchin removal tool. I'm gonna go grab an urchin so I can show it to you. No urchins will be harmed. I will get it, I will show it to you, and then I will put it back. Although I kind of want to eat it. If you've ever had uni sushi, that is urchin gonad. Urchin gonad. They're reproductive organs. Fun times. Oh, and if you want to get them, there's some fishermen here grabbing some fish. So, kind of cool. Okay, I'm going to do it. So in this little grotto here, you have the coralline algae, the encrusting coralline algae like I mentioned before. You also have the branching. Like I mentioned, there's encrusting and branching. Here's that branching. I showed you this before, but you have branching and all the encrusting down there as well. So let's go grab an urchin. Let's go grab an urchin. Oh God, I feel like the urchin hunter. I think I can make a whole show, the urchin hunter. It'll just me with a key. I'm sorry, an urchin removal tool. Okay, let's get it. And here what's kind of cool too, you can see all the barnacles. So barnacles can be found all over, especially in higher environments. And I mentioned, oh, can you get a close-up on this? You can see the difference between that. Here, I'm gonna grab your phone. I just wanna show you the two main species here. I mentioned Balanus and Cathamalus. Here, so Balanus is mainly found lower in the intertidal. Here, so the Balanus are the larger ones. The Cathamalus are the smaller ones. So here you have a few Balanus, the larger ones, and the smaller ones, the Cathamalus. So Balanus actually are much better competitors than Cathamalus, but Balanus can only be found in the lower regions, while Cathamalus, like we saw earlier, they're found in the higher ones. So I'm going to give you back to our camera person, and I'm going to get that urchin like I promised. We have purple urchins down here. I have my urchin removal key. I can do it. Oh God. If I don't get it. Oh. Here we go. So, urchins and sea stars are the same phylum. They're very closely related. So remember I told you about the tube feet and you saw the tube feet on the starfish? These have tube feet as well. That's how they move around. You can't really see it because it's out of the water, but they have tube feet and that's how they move around. A difference is these have the spines. These have the spines. Sea stars have spines too, but they're very, very small if they have them at all. We saw the spines in the Ocratius, very small spines, and no spines at all in the bat star. But as you can see in the urchins, very, very spiny. These tend to feed on algae. So the starfish, they tend to feed on mussels. These feed on algae. So there's our urchin. I'm going to put it back. No urchins were harmed in the filming of this. And what's kind of cool, I'm going to put it back in this little hole. They actually burrow holes. They make little holes for themselves in here. So all these urchins down here are in their own holes. Kind of cool. So I'm going to show you one more thing, and then we're going to call it a trip. But first, let me return my urchin removal tool to our camera person. Thank you, camera person. This is freaking amazing. So I brought some sponge. I found some sponge down in this little area here, this grotto. Call it a grotto. Is it really a grotto? I'm just calling it a grotto. Maybe I heard it in a movie somewhere. I don't know if this is officially a grotto. A little cavern, a little space. But I found sponge down there. There's sponge close up for you. Okay, and I looked down here and I saw something that looked like a sponge. I thought it was a sponge, but then I'm like, wait a second, it's by itself. Sponges wouldn't be on a rock. I found it on that rock right there. Oh, crab! Crab! I just noticed a crab. I'm gonna try and catch it in a second. There's a crab right there. There's a crab moving. You see it moving? Film girl? It moved away. You saw the crab? You got the crab. Okay, so this is not a sponge. This is a mollusk called a nudibranch. A nudibranch. So I turned it over and I'm like, oh, it's a nudibranch because it has that little bottom like a snail. It is related to a snail. It's a gastropod, which is the same class as a snail. It's called a nudibranch. It's basically a beautiful creature in the ocean. I'm gonna put it back in the ocean. Maybe we can see it swim, I don't know. I wish I brought a little clear container where we could put water in, but oh well. I didn't realize we were gonna find all this stuff. So all that stuff down there, all that orange stuff, that is sponge. This is a frickin' nudibranch. I'm so excited. a nudibranch. I think I'm going to name this nudibranch Nate the nudibranch, or Natalie. I'm not sure if it's a male or female or both. So Nate or Natalie the nudibranch.